Hey folks, so in this video, I want to talk a little bit about BFS versus DFS, right? So depth first search versus breadth first search. Now, overall, right, they are kind of solving the same problem, right? They're solving the problem of how do I get from one point to another point in a graph, right? So if I have nodes A and B that are somewhere in my graph, I just want to know, are they connected or not? Both DFS and BFS will find me that answer, right? I'll get them to both be marked nodes. I'll know that I was able to get there, right? So from that standpoint, they're the same. So where are they different? They're different in terms of the path they take to get somewhere. So let's take a look at the trace on the right-hand side. So left side, I have basically DFS. So DFS in this diagram, right, maybe this is my starting node. And if I kind of look at my images, the way I've kind of done this visualization here is that the darkened node labels indicate that I've explored them, right? So DFS basically starts by, starting at the first node and moving to its neighbor, right? Moving to its neighbor, then moving to its neighbor's neighbor, its neighbor's neighbor's neighbor, neighbor's 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 neighbors, right? This is basically the path that I'm taking with a DFS node, right? I'm basically just going to every node, right, and going kind of to just one of their neighbors. I'm repeating this again and again and again. I'm basically going very deep into the graph. Now, if I do this, I'll definitely get to every node in the graph, but the path that I take to get there might be a little bit long. Let's look at BFS. So BFS, it's like I start here, right? Start here, right? And then I kind of go a little bit deeper into the graph, right? So it's like, well, I start here, and then maybe I go out to its neighbor, right, to here, then go out to its neighbor's neighbor, right? And somehow, right, it's like I'm basically staying kind of close to home, right? So DFS, right, in this point over here, right, DFS would kind of continue going to 5. It would go basically deeper in the graph, right, farther from 0. BFS doesn't do that though. BFS basically says, I don't want to go that deep. I'm going to stay close to the origin, right? And so instead of going over here and exploring 3, right, instead of exploring 5, it explores 3, right? These charts don't quite line up just because of the number of nodes. But the point is, right, is instead of going deeper and deeper and deeper, I'm staying close to the origin, right? You're staying close to the origin, right? You finally fill in 4 as well, right? Now it's only once you fill in 4 that you go to 5, right? So 5 is actually kind of your very last thing, which kind of makes sense from the standpoint of it's pretty far from your origin, right? It's pretty far from 0, okay? So we have kind of these two different mechanisms that are both about moving through the graph. So basically, your mechanics overall is that for DFS, you're saying, I am going to extend my path based on the most recent thing I've seen, right? It's going for depth first, right? So the newest thing is the most interesting thing for me, so I'll go pursue exploring the graph through that. Versus BFS is saying, no, I want to do the opposite. I'll explore my graph by going through the oldest thing that I've seen, right? So the last node that I saw, or the node I first saw right at the very beginning of time, that's the one I want to explore by, right? So one's looking at exploring from the newest node, the other one's looking for exploring from the oldest node, right? And that gives us very different behavior. DFS is kind of something that's basically going to run through your graph, go really deep, versus BFS starts in the origin and works out, and works out, and works out, right? So they have different mechanisms overall. Now here's a question, right, for you guys that you may think about for a second. If we didn't know the size of a graph, which algorithm would be safer to use? Would it be safer to use DFS or BFS? Take one moment and think about that. So the answer here is that BFS is going to be a lot easier, right? Or not easier, but a lot more sane to use. So the problem with DFS, right, is you imagine you have a size of graph, you don't know how large it is, DFS might just get lost, right? So you imagine you have a graph that's very large, right? Maybe you even have an infinite graph, right? So infinite graphs are another thing you can maybe think about traversing. If you have an infinite graph, your DFS might find one of those infinite paths, basically get lost out, right? And go explore everything off on this one side and never even see lots of the other stuff that are near the origin point. So that would be an issue, right? If I don't know how big my graph is. For something like BFS is basically going to systematically go out from the origin, so it's not going to miss anything, right? It's not going to get stuck in any path that goes on forever and just never explore anything else. It's going to systematically inch out and see everything in the graph. So if I have a graph that I don't know its size, probably BFS is going to be a better way to go. All right, let's see. Before I end this video, I guess I'll add to that. One question for you guys is maybe this. When would I see an infinite graph? Is such a thing even possible? Well, sure it is, right? So an infinite graph is very common in AI applications because you may actually be creating your graph dynamically as you choose what to do, right? So in an AI device, right, you're like, well, I need to make this choice. If I could do X, Y, and Z, right? And then you do X, and it's like, well, I have the choices A, B, and C afterwards, right? You have choices under choices under choices. Well, if you're trying to do planning for how do I do something overall, right? How do I achieve this goal? I could have, a ton of steps there, right? Basically, I have an infinite number of steps. And so a lot of times, right, the graphs you're trying to explore when you're solving an AI problem and looking like kind of this infinite graph, right, of all these different choices I could possibly make. So it's definitely something that does show up in practice, right? So we do need to worry about, right, infinite graphs. So anyways, yeah, BFS would probably be the way to go there. DFS is just going to get lost. All right, so that does it for our coverage of BFS and DFS. In the next sequence of videos, I'll start talking about a couple of graph theoretic applications of these algorithms.